Hello everyone. So today we are going to work on writing chemical equations and word equations. So let's talk about what those terms mean. First of all, a mathematical equation is something with numbers and symbols, like the symbol for number 2, the symbol for plus, and so forth. Okay. A word equation for the same thing would say the same exact thing but with words. Okay. 2 plus 2 equals 4. So this is a word equation right here. And this is a mathematical equation, where chemical equations are the same way. You can have a chemical equations with the symbols, or you can have a word equation that's a sentence that tells you what's happening. Okay, so we're just going to practice the skill of writing the whole thing here with a few examples. So here I have hydrogen gas. Okay, remember that's a diatomic molecule. If you don't know what that is, we're going to talk about it here in a couple of slides. But I have hydrogen gas, so I'm going to go from a chemical to a word equation. Okay. Hydrogen gas is reacts with oxygen gas to produce, so that's the arrow, liquid water. And there we go. Okay, so it's as simple as that, going from the chemical equation to a word equation. Over here, we have a different reaction. Now remember, we don't need to mention the coefficients, okay, when we're writing the word equation. But here, for example, I'm going to say sodium metal, or we could say solid sodium, okay, reacts with chlorine gas to yield, which is the same thing as to produce or to form. All those words mean the same thing. Sodium chloride. Now, NaCl is an ionic compound, so I know how to name my ionic compounds. I could say yield solid sodium chloride because it tells me it's a solid. Okay. Here, for example, I could say solid lithium. Again, there's not just one correct answer to do this. Okay. And liquid water, I'm going to abbreviate a little bit. React to form. So what do we form here? Aqueous LiOH. So that's lithium hydroxide. So I could say aqueous lithium hydroxide, or I could say dissolved lithium hydroxide, or a solution of lithium hydroxide. So I'll just go ahead and say that. All of those mean the same thing, a solution of lithium hydroxide. And then my other product is hydrogen gas. So I'm going to say and hydrogen gas. So there we go. So those are three examples of going from a chemical equation to a word equation. Okay. Now a quick review of diatomic molecules. So there are 7 of them, okay, in the periodic table, and most of them make the shape of a 7. There are these guys over here. So see how they kind of make the shape of a 7, but it also includes hydrogen. So hydrogen's kind of out there. But when we say hydrogen gas, for example, we never mean H, we mean H2. Same thing with nitrogen gas, oxygen gas, fluorine gas, chlorine gas. Bromine's a liquid at room temperature, so it'd be liquid bromine. And iodine is a solid at room temperature, okay? But anyways, these 7 here, they are always in pairs. So if I say oxygen, never, or anybody, you never just mean O, you mean O2. Now this is only when it's just an element, okay? So for example, if oxygen is bonded to sodium, it's Na2O, okay? But if we're talking about oxygen, pure oxygen gas, it's O2, all right? So diatomic elements in the elemental form, okay? All right, let's move on. So here, we're going to go from the word equation to the chemical formula, all right? And at least for my students, this is what you're going to do a lot of in the next few days here. So I'm going to read this. Solid iron can rust in the presence of oxygen gas to produce iron oxide, okay? So I know that solid iron is going to be FeS, and then it can rust in the presence of oxygen gas. So I'm going to write that down here. FeS, and then oxygen gas, remember, is O2. And then it's going to produce iron 3 oxide. So this is an ionic formula, so it's going to have charges. Iron 3 is iron with a positive 3 charge, and oxygen is a negative 2 charge. I know that by looking at the periodic table, and iron, it tells me right here the charge of iron. So this formula is going to be Fe2O3. And it doesn't tell me the state of matter here. I happen to know it's a solid. I guess I forgot to write that down. But if we go back, and if we need to balance this equation, I'm just going to do it real quick here. There we go, we balance the equation. So remember, we write the formulas first, and then you go back and balance, all right? The gas is nitrogen dioxide, and oxygen react to produce dinitrogen pentoxide gas. Okay, so all of these here are covalent things, so I'm not going to worry about the charges of anything. So it says the gas is nitrogen dioxide and oxygen. So nitrogen dioxide is going to be NO2 gas plus oxygen gas. And it's saying that it's producing a third gas, dinitrogen, so that's N2 pentoxide, O5 gas. Again, these are covalent. I'm not worrying about the charges. I'm just using the prefixes to write my products. Then I got to go back and balance this. Time to balance this because you already know how to balance, but the coefficients would be 4, 1, and then 2. Okay. All right, let's move on to our last slide here. Okay, so now we have 2 more examples here. I would go ahead and take a minute to try these out, pause the video, and then watch the answers. Okay? So I'm assuming that you already read this. First part I'm going to work out is this dissolved sodium bicarbonate right here. So sodium bicarbonate is an ionic compound. Sodium is a positive 1 charge. Bicarbonate is HCO3 with a negative 1 charge. Okay? Dissolved means it's aqueous. So I'm going to have NaHC, aqueous. Okay? Now, that is going to produce some other stuff when it's heated. Remember, heating, we put a triangle over the arrow to mean heat. If we're using a catalyst, you actually write out the formula of the catalyst. So, for example, if you're using platinum as a catalyst, you would write it like that. If you're using potassium iodide, you write it like that over the arrow. Okay? Now, the first thing we produce is sodium carbonate. So again, this is ionic. Sodium is a positive 1. Carbonate is a negative 2. So this is going to be Na2CO3. That's aqueous. It tells me we do carbon dioxide gas. And then water. So water, if it just says water, we can assume it's liquid. Okay. So the next thing we do is balance. And to balance this, the only thing we got to do is put a 2 right there, okay? And then the equation is balanced. Last one, nickel 2 hydroxide. Again, ionic. Nickel, positive 2. Hydroxide is a negative 1, okay? NiOH2. Now, it doesn't tell you what the state of matter is. Because it's ionic, I'm just going to assume it's a solid. Because solids ionic compounds are always solid at room temperature. So unless it tells me otherwise, if it's ionic, I'm going to assume it's a solid. This is going to decompose to produce, so that's an arrow, nickel 2 oxide. So again, nickel, a positive 2 charge, oxygen with a negative 2 charge. So that's NiO. Again, doesn't give me the state of matter. I can assume it's a solid. And then water. I can assume it's a liquid. Now, that being said, if the equation doesn't give you the state of matter, you don't have to include it, okay? The states of matter are not totally essential to a chemical equation. They are just helpful. So if you're told, you can include it. If you're not told, you can exclude it. Or if you can just figure it out like this, then you figure it out. And that's it.